we are taking General Revision 1 about static subject. What is this static subject? We have General Revision included Unit 1 to Unit 6. My dear student, look at the first example. A body of weight 39 kilogram weight is placed on horizontal rough plane, two forces of magnitude 7 and 8 kilogram weight and included an angle of measure 60 degree act on the body. So it become about to move. Then the static coefficient friction or mu equals what? Look at, my dear student, at the first, F equals square root 7 power 2, 8 power 2 plus 2 times 7 times 8 times cosine theta, cosine 60. We know that, my dear student, N equals W, F equal MSN. Therefore, 13 equals mu SN. Therefore, mu SN times 39 equals 13. What is the coefficient? Equals third. Look at, my dear student, if we have body weight 39 Newton placed on a rough horizontal plane, the tangent of the static friction angle between the body and the plane is third. Don't forget, tangent of the static friction angle between the body and the plane is third. The body is attached by force inclined the horizontal by an angle whose sine of this angle is 4/5 makes the body is about to move. What is required? Find magnitude of the tension forces. My dear student, look at in the first, we have the force F act on the body inclined with angle theta with x-axis. Then we resolve the force F into two components. The first component F cosine theta, second component F sine theta. Don't forget, my dear students, the body its weight 39. We have reaction force N and mu Sn opposite the force F cosine theta. In horizontal, my dear student, we have two equations. First horizontal equation, second vertical equation. The first F cosine theta equals mu Sn. This equation number 1. By substitution about cosine theta equals 3/5 and mu S equals third. Then this relation have F and N unknown. 3/5F equals third N. By vertical equation, F sine theta plus N equals the weight equals 39. Then by substitution about sine theta equal 4/5. Then we get the second equation 4/5F plus N equals 39. Then we have two equations in two unknown variables, F and N. Therefore, we find N from equation 2. N equals 39 minus 4/5N. By substitution about N from 3 in one equation or in first equation, then therefore 3/5F equal third multiply bracket contains 39 minus 4/5F. Therefore, my dear student, 3/5F equals 13 minus 4/5F. We add like terms, therefore 13/15F equals 13. By using cross multiplication, then we find F equals 15 Newton. My dear student, this example is very important. We have the force which acts the body. The force inclines the on horizontal x-axis by theta. Then we resolve the force into two components. The first component in x-axis F cosine theta, second component in vertical y-axis F sine theta. And we form two equations, horizontal equation and vertical equation, to calculate the required the force F. Look at another example. If we have I, J, K are right system of unit vectors and the force F equals 3I plus 4J. This force act at a point A, negative 1, 3 of the body. Find at the first moment of the force F about the origin point. What's the meaning of the origin point? 0, 0. Number B, the length of perpendicular segment from the point O. My dear student, we know that the moment equals R cross F. In this example, the force has two coordinates and R also has two coordinates. By using the R cross F to calculate the moment of the force. Look at moment of the force about origin point O equals R cross F. What is the meaning of position vector R? What is the meaning of the force? Then by using R negative 1, 3, this force point, cross 3, 4, the force. Then we know that, my dear student, when we find R cross F, this is the vector product. Vector product means R cross F x1, y2 minus x2, y1. What you mean? Negative 1 times 4. Negative 1 times 4 minus 3 times 3 equals negative 13k. Then the moment about the origin point equals negative 13k vector. Now we are translate to find the length of perpendicular. My dear student, what is the length of perpendicular rule? Excellent student. L equals norm moment over norm F. What is the norm moment? 13, or absolute of moment negative 13 must be positive 13 over square root 3 power 2 plus 4 power 2. This is the norm of the force F. Look at 13 over 5 equal 2.6 length unit. Don't forget, my dear student, the length of perpendicular, this very important rule. We find this example in all exams. L equals norm or absolute of the moment over norm F. Now we are translate to another one. The force F equals 2I minus J plus 3K. Act at the point negative 3, 1, 2. Find moment of the force about the point B 2 to negative 1. Then find the length of the perpendicular from the point B to the line of action of the force. My dear student, in this example, we know BA vector equal point A minus point A, point A minus point B. Therefore, by subtract each component from the corresponding, then BA vector equals negative 5, 1, negative 1, 3, negative 5, negative 1, 3. After that, moment about B equals R vector cross F vector. But in this case, we have the point in 3 dimensions. Also, the force in 3 dimensions. We must find the moment about B by using determinant. What is the meaning of determinant? The first row IJK, second row component of R, negative 5, negative 1, 3. The third row component of the force F, 2, negative 1, 3. Therefore, by using determinant, the first 0I plus 21J plus 7K. Remember, my dear student, we have two cases to find the moment about the point. In 2 dimensions, R cross F, x1, y2 minus x2, y1. But in 3 dimensions, we must use determinant ijk is the first row, second row component of the point or component of r vector, third row component of the fourth vector. Then the moment about point B equal 0i plus 21j plus 7k or 21j plus 7k. Remember, what is the meaning of norm of moment? Norm of moment is square root 21 power 2 plus 7 power 2. After that, my dear student, look at in the opposite figure the norm of the sum of moment of forces about the origin point C equals what? Look at in the opposite figure the required the sum of moment at point C. How many forces? We find 100 Newton. This is the first. Second force 80 root 2 Newton. And 80 root 2 inclined with horizontal with angle 45. And the distance between A and C 20 centimeter. Distance between B and C 25 centimeter. Look at, my dear student, what is the norm of sum of moment of the forces about the point C. Choose the correct answer. 0, 22,000, negative 22,000, or 2,200. My dear student, in this example, we have two forces. 100 act at A, 80 root 2 Newton act at B and inclined with 45 degrees with horizontal BA. To find the moment about C, then look at direction of the force 100 anti-clockwise, then 100 times 20. Plus or minus 80 root 2 times distance 25 cosine 45. My dear student, look at 100 times 20 minus 80 root 2 times 25 times sine 45. Why sine 45? Because the perpendicular from the force 80 root 2 and the point C is 25 sine 45. Why? Because the perpendicular is the opposite 45 equals sine 45. Therefore, answer is 0. Look at another one. Two parallel forces of magnitudes 20 and F Newton act at the 2 points A and B. The magnitude of their resultants is 35. Remember, my dear student, we have resultant of the two forces 20 and F is 35, more than 20. The resultant acts at point C. If AC equal 15 centimeter, then what is the length of AB equals? Look at, my dear student, we have the force 20 act at the point A, and the resultant between the two forces 20 and F in same direction is 35. 35 act at point C, and the distance between A and C equal 15 centimeter. The required AB equals what? Remember, my dear student, at the first, what is the value of the force F? We know that if we have two parallel forces in same direction, R equals summation of two forces. R equals F1 plus F2, 20 plus F, therefore F equals 15. Then, after that, we find BC length by using the force F times BC equals 20 times AC. To find the BC, after that we add BC plus AC to calculate length of AB. Look at, my dear student, BA or length of AB equal what? Choose the correct answer. 15, 35, 45 or 20. Look at the first, the resultant more than given force. Then the two forces in same direction. 35 more than 20. Therefore, two forces in same direction. The resultant of the two forces are equals F1 plus F2. Therefore, F equals 15. My dear student, by using the rule, 20 times 15 equals 15 times BC. In this case, BC equals 20 centimeter. Therefore, the length between the two forces or AB equals 15 plus 20 equals 35 centimeter. Then the correct answer is 35. Now we are translate to another example. A, B, C, D, H are 5 points on straight line where AB equal DH equal 20 centimeter, BC equals 30 centimeter. CD also equals 6 centimeter. We have three forces of magnitudes 15, 25, 35 Newton act at A, C, and H in same direction and perpendicular to H. Two forces of magnitude 20 and 30 Newton act at point B and D in the opposite direction to the set of first forces. What is the required? Find R of the or resultant of the forces. Look at, my dear student, in the opposite figure, resultant we suppose is R and acts at distance x centimeter from point A in direction of the greatest force. What is the greatest force? Look at, my dear student, we know that the resultant of the forces must lie on the same direction of the greatest force. We have two forces up and three forces down. Summation of the two forces up 20 plus 30 equal 50 Newton. But in down 35 plus 25 equals 60 plus 15 equals 75. Then R must lies on the point O with same of the biggest force downward. My dear student, in equilibrium we must R equals 15 plus 25 plus 35 minus summation of 30 plus 20 to find the value or magnitude of R. After that, we find the moment about the force, a moment of the force or the resultant about point A, moment about A equals 0. Look at, my dear student, in this example, we find the magnitude of R by using 15 plus 25 plus 35 minus summation of up forces 30 plus 20, answer is 25. Then the resultant is 25 Newton. After that, we find moment at a point A. Moment about point A, negative 20 times 20. Why? Because 20 is same with clockwise. Clockwise direction, negative direction, but anti-clockwise positive direction. Then moment about A, negative 20 times 20 plus 25 times 50 plus or negative 30 times 110 plus 35 times 130. Remember, my dear student, the moment about point A equals moment of the forces equal moment of the resultant multiply the distance is x. We suppose the distance between R and the point A, x. Therefore, 25x equals negative 20 times 20 plus 25 times 50 minus 30 times 110 plus 35 times 130 to find or to calculate the length of x divided 2100 among 25. Answer is 84 centimeter. Then, my dear student, the resultant r equals 25 as a distance 84 centimeter from the point A. Now we are translate to another example. AB is a rod of length 60 centimeter and its weight 400 grams. The weight, 400 grams weight, acting at its midpoint, rests on support 20 centimeter distance from A. Remember, we have AB is a rod. Its length 6 centimeter and its weight 400 gram. Weight act at midpoint. After that, the rest of support 20 centimeter distance from point A. The rod kept horizontally in equilibrium by a light vertical string connected to point B. What is the required? Magnitude of each of the tension in the string and reaction of support. Number 2, magnitude of weight that should be suspended from A to make the tension in string is about to vanish. Look at, my dear student, we have AB is a rod. We have support at point C, support at point C, there is R or reaction upward, and we have tension T at point B. My dear student, we know that R plus T equals the weight of the rod, 400. This is the first equation. And after that, we find the moment at point C. Moment at C equals 0. Therefore, what is the moment at C? Look at the forces which act at C. We have 400, the weight of the rod, and R, this R equals 0. Why? Because the moment at C we means R equals 0, but the tension multiply the distance between B and C. Therefore, 400 times 10 minus T times 40 equals 0. From this equation, easy to find the value of the tension T. Therefore, the tension T equals 100. Then, to find R, subtract 400 minus 100 equals 300. This R. My dear student, T equals 100 and R equal 300. In this example, we have forces up equal forces down. What is the forces up? T and R. Tension of the force and R reaction of the support. And 400 is the weight of the rod. Therefore, we know that R plus T equals 400. We have equation in two variables. We need to calculate one of them. We find the moment at point C. Moment at point C, we calculate tension. The tension equals 100 Newton. After that, R equals, or reaction on support C, 300 gram weight. After that, when T vanish means T equals 0. Moment about C equals 0. Therefore, we have two forces only. The W times 20 and 400 times 10. But 400 times 10 was positive, but negative W times 20. Therefore, to calculate the weight equals 200. Now we are translate to another example. A uniform ladder of weight 20 kilogram rests in a vertical plane with one end on a rough horizontal floor and the other end against a smooth vertical wall. The ladder is inclined at 60 degrees to horizontal, given that coefficient of friction between the ladder and the floor equals 1 over 2 root 3. What is the required? The maximum distance a man of weight 60 kilogram can ascend up the ladder is equal to half length of ladder. What do you mean? The distance, if the ladder equals 2L and the distance of the man between the man and the bottom is X, must prove that X equal L. Therefore, my dear student, in the opposite figure, we find RA equals 20 plus 60 equal 80 in vertical, but horizontal equals RB equal 1 over 2 root 3 RB equals 40 root 3 over 3. Therefore, moment about A, by using the moment, we calculate the X and L. We know that X equals L. 30X plus 10L minus 40L equals 0. Therefore, X equals L, or X equal half length of the ladder. My dear student, by the end of the lesson, I'm very happy to spend such time with you. Thank you. Goodbye.